Hello, my name's Gabe. For this problem, we're asked to show that the equation y equals 8 divided by 1 plus e to the negative 2t is a solution to this logistic differential equation. Now, assuming that y is a solution to this logistic differential equation, we can make a few quick notes. First of all, we'll see that L is equal to 8, K is equal to 2, and B is equal to 1. So now to start showing that this is a solution to this differential equation, let's start by rewriting y as 8 times 1 plus e to the negative 2t to the negative 1. This will just simplify our derivative. So first of all, we have dy dt is going to be negative 8 times 1 plus e to the negative 2t to the negative 2. And we have to multiply this by the derivative of 1 plus e to the negative 2t, which is going to be negative 2 times e to the negative 2t. Now that we have our derivative, we want to show that it satisfies this logistic differential equation. So the first thing I'm going to note is that we have k equals 2, and we do have a 2 appearing in our derivative, so we can bring that out in front. And I'll also note that we have a negative times a negative, so the negatives will become a positive. So we can write this as 2 times 8. I'm going to rewrite 1 plus e to the negative 2t to the negative 2 as 1 divided by 1 plus e to the negative 2t squared. And we're multiplying this by e to the negative 2t. So now, I want to write this as k times y, and I'll note that y is 8 divided by 1 plus e to the negative 2t. So I can rewrite this as 2 times 8 divided by 1 plus e to the negative 2t. So notice here, this is squared. Here I'm only going to use one of these. And I'm going to be left multiplying this by e to the negative 2t divided by 1 plus e to the negative 2t. So now what this is starting to look like is k times y. Now I somehow need to rewrite this as 1 minus y divided by L. So just like this, I can't cancel, but a trick that I can do is I can add 0 to this numerator. So I can add 1, and then subtract 1. And what I'm going to do is I'm going to break this up into two separate fractions. So here I'll have 1 plus e to the negative 2t. And here I'll have 1 plus e to the negative 2t. So verify that from this step to this step, I haven't changed anything. All I've done is add 1 and subtract 1. So I've added 0 to this numerator. So we'll continue on simplifying. This is 2 times 8 divided by 1 plus e to the negative 2t. Now 1 plus e to the negative 2t divided by 1 plus e to the negative 2t is 1. And now I want to somehow write this as y divided by L. So I know that in this case L is 8, so let's multiply both the numerator and denominator by 8. So I'll have 8 divided by 8 times 1 plus e to the negative 2t. So looking back, well, we said that 2 was equal to k. 8 divided by 1 plus e to the negative 2t was y. Here we have a 1. And 8 divided by 1 plus e to the negative 2t was y. And we still had to divide by this 8, which we already said was L. So we've shown that y is a solution to this logistic differential equation. Now the last thing we want to do is we want to find the initial condition. So to find the initial condition, all we're looking for is y when t equals 0. So we're looking for y of 0, which is 8 divided by 1 plus e to the negative 2 times 0, which is 8 divided by 1 plus 1, which is 4. So the initial condition is y of 0 equals 4. Thank you.